CTA Traction Power System Upgrades is a public infrastructure improvement project for the Chicago Transit Authority, the bureau in charge of all bus and train lines in the city. It is a multi-part project consisting of 3 separate electrical substations, along with 27 column footing replacements and other miscellaneous electrical improvements. The project is needed to improve electrical power flow to the CTA elevated tracks for both the Brown and Red Line trains, which serve over 350,000 people daily. The project is a design, bid, build contract totaling $47 million, 17 of which is for electrical scope. Each substation is located along the CTA Red Line on the north side of Chicago. Since all 3 substations share similar characteristics, we chose to examine one particular building along with the footing replacements. Our project is located in Chicago, Illinois at 945 West Armitage Street in the Lincoln Park neighborhood. We will refer to it as Armitage. The project management structure is the following. The project owner is the Chicago Transit Authority, or CTA. Architect of record is Larimore, Douglas, and Popham Incorporated. Construction manager is STV Inc. General contractor is FH Passion and SN Nielsen. Along with these 4 major players, there are 13 subcontractors performing all trades except concrete, which will be self-performed by FH Passion. FH Passion is a general contractor based in Chicago, Illinois. They have performed several projects for the CTA, including a $49 million station rehab currently in progress. Our contact for this project was Jim Brick, the project superintendent. The past 10 years he's been with FHP, he has done 6 CTA station rehabs and 1 entirely new station on his most recently completed project, located at Morgan and Lake Street, Chicago's West Loop. Along with Jim, the FHP project team consists of a project manager, 2 project engineers, and an office manager. There are numerous challenges for this project, both small and large. The first challenge the construction team must deal with is the location of the project. Lincoln Park, home to over 65,000 residents, is a densely populated neighborhood located on the north side of the city. Working in such a populated area creates challenges in material and equipment deliveries. In such a congested area, there is nowhere for trucks to wait without disrupting the daily operations of nearby stores and residents. This means the superintendent and subcontractor must be continuously coordinating orders with their material suppliers so there's not a cluster of vehicles reaching the site at the same time. Laborers and flaggers need to back trucks in swiftly in order to avoid problems with the area's residents. The trucks were constantly blocking the street. Residents would put in complaints to the city, which would cause problems for FHP. The second challenge of this project is the size of the site. It's an extremely small site with almost no room for staging. There's also minimal room to maneuver trucks and equipment due to the columns from the elevated structure and its generally low height.
Permit issues have caused the start of the project to be delayed.
Knowing their excavations would exceed 12 feet below grade, FH Passion assumed it would need an existing facility protection review from the Chicago Office of Underground Coordination, or OUC, before they could receive work permits from the Department of Buildings. Passion did not submit an application to the OUC because the CTA informed Passion during an October progress meeting that such a review would not be necessary. It wasn't until November that Passion was contacted by the Department of Buildings, informing them a facility protection review would be necessary.
This review lasts 30 days, and all construction activities have to be delayed while it is taking place. The total duration for the project is projected to be just under 2 years.
Prior to starting the demolition of the substation, the planning process should include an engineering survey of the location. A structural engineer must also assess the condition of the framing, floors, and walls to look for the possibility of an unexpected collapse. Before demolition, all utilities must be disconnected from the building. Since the job site area is very limited, all demolition material must be removed from the site as quickly as possible. Any leftover debris can also pose a fire hazard, which would not be in compliance with the CTA safety specification. In addition, the demolition material must be kept away from the railroad's right-of-way since the train will continue to run during the duration of the project. FH Passion has developed many different procedures to help keep the job site safe and secure. To prevent robbery, FH Passion will place burglar alarms and motion detectors on their trailer. Their containers and cargo boxes will also have padlocks and padlock shields. Since materials will be kept overnight on the job site will be under 24-hour surveillance. Finally, the safety management program suggests that copper wire be painted black to keep thieves from spotting it on the job. Because the CTA project is in close proximity to urban areas, schools, and residential and commercial businesses, there are many procedures aimed toward protecting the public. 8-foot chain-link fence with green screening will be placed around the job site. This fencing may not be substantial enough to prevent debris from leaving the job site. Because of this, hoardings and other physical barriers will need to be erected during construction activities that produce debris. One example is using Hessian screens around welding locations.
The excavation is subcontracted to Stallworth Underground. The excavation will allow a replacement of common footings and the construction of the cable vaults. The wedding cake foundation is replaced with spread footing. One problem is that the train tracks are low. Because of this, a mini excavator has to be used for digging. Also, a vibrating hammer is attached to the mini excavator instead of a bucket in order to grab the piles and drive them into the ground. Earth retention is necessary in order to install the proposed footings. The subcontractor is also responsible for designing all struts, wailers, H-piling, and laggings. The excavation process will also involve a dewatering phase to prevent the softening of foundation bottoms. Since the project is performed on an active train line, temporary shoring is essential. The columns are temporarily supported by girders attached by C-channels and I-beams. One last responsibility of the subcontractor is to locate the existing utilities before excavation and make sure they're supported during the whole process.
All the foundation of the cable vault will be constructed out of concrete, which will be self-performed by FH Passion. However, cable vault construction cannot start until the track foundation and piers are complete, which will also be made of concrete. The concrete scope of this project includes the 27 column footings, the mat slab and foundation wall for the electrical substation, exterior equipment pads, and cable vault roofs.
After soldier pile walls are up and the demolition of all the foundation is done, they're going to pour a lean layer of concrete underneath, then put formwork on top, put some spacer blocks, add reinforcement bars, add more reinforcement bars, and add reinforcement bars for the stump, add more ties to the formwork, and pour some concrete and voila!
Cast-in-place concrete will be used for this construction, using simple plywoods with resin coatings and non-exposed cone-type form ties. Reinforcement will be used in every place where cast-in-place concrete is used. The reinforcement bars will consist of grade 60 deformed bars. The rebars will be assembled on site.
After the foundation for the tracks are done, they'll start working on that foundation for the cable vault. The form will be moved after the concrete has reached 70% of its design strength. The finished foundation should look like this. And that is the end of the foundation.
Once concrete is poured, masonry can begin. Since this project is heavily electrical, the mason will have to work with the electrician to organize wall cutouts for conduit. The masonry subcontractor for Armitage is Garth Construction Services. The scope on this project is quite simple, consisting of 8-inch CMU walls veneered with standard, modular-sized face brick. Face brick is a running bond with 2 solder courses located 8 foot up on the wall. Joints are to be tooled concave and are to be reinforced for every second CMU course. Overhead door openings will be spanned by tubular steel beams, while personnel entrances will consist of solid grouted hollow metal door frames spanned by bond beams. All masonry walls are to be grouted solid and reinforced with half-inch rebar.
Along with masonry, the steel scope for this project is relatively simple and repetitive. The majority of the steel construction consists of installation of new connections between the elevated structure's columns and the new concrete footings. Also in the steel scope is a chain link fence covering the courtyard between the AC and DC cable vault. The steel erector on this project is Metropolitan Steel, and the fabricator is Web Production Framing. Many of the old column bases are dilapidated and rusty and need replacement. After the footing is poured and ready to connect to the new column, Metropolitan must drill holes into the existing columns to attach the plates and bolts securely to the new base.
After all this work are complete, the electrician will arrive on site to install electrical conduits, power distributor, AC-DC converter, and other electrical works we will not cover in this project since they are out of our scope. But here is the drawing of what the finished structure should look like. Enjoy!